we can talk about symmetry in terms of whether it's symmetric about the x-axis, the y-axis, or the origin. All right, and when we do that, we're basically talking about a relation. So a relation, not all relations, but some relations have symmetry with regards to either the x-axis, the y-axis, or the origin. And it can have symmetry with all three of them. All right, so that's what we're going to talk about. Now, remember, I said some relations, not all relations, some relations. So we're only looking at certain kinds of relations. Now, to talk about symmetry in terms of these three types here, let's look at this graph. So I'm showing you this graph. And on one of your My Math Lab assignments, you had to graph basic quadratic functions. So that was a My Math Lab assignment, and I forgot what topic it was. But this is the graph of y equals x squared. Now I want you to notice something. So here's the y-axis, right? So if you look at this part of the parabola right here, if you look at this part of the parabola, and if you were to reflect it, so if you just take this part here, and if I trace over it, let's see if that's going to make a difference. So if I take this part here, right here, and I reflect it about the y-axis, I get this part. See that? So this relation, which is also a function because it does pass the vertical line test, but this relation is symmetric about the y-axis. All right, so this right here has y-axis symmetry. All right, so y-axis symmetry. And most times, almost all times, you can tell very easily, probably all the time, you can tell very easily whether, if a graph is given, whether it's symmetric about the y-axis, the x-axis, or the origin, or whether it has no symmetry at all in terms of those three. So, so again, this has y-axis symmetry because if I take one part of it, reflected about the y-axis, I get this part as well. Now, a couple of things that's important to know. When you have y-axis symmetry, I want you to notice something. You see this point right here? That point has coordinates 2, 4. If you look on, if you were to reflect this, if you were to reflect this point about the y-axis, you get this point right here, right? So if you look at it, that is the point -2, 4. So I want you to notice the y coordinates are the same, but the x coordinates are opposites. So whenever you have y-axis symmetry, so if you have this point here, which is 2, 9, oops, sorry, 3, 9, excuse me, 3, 9, because remember 3 squared is 9. So 3, 9, and you reflect it about the y-axis, then you're going to get the point -3, 9. So notice +2, -2, +3, -3. All right, so what that means is this now. Listen to what I'm about to tell you. A relation, well, let me do it this way. To determine if a relation has y-axis symmetry, okay, to determine if a relation has y-axis symmetry, notice 2, the x-coordinate, 2, -2, x-coordinate, 3, -3. The y-coordinate stays the same as the x-coordinate that changes, okay? So if you want to determine if a relation has y-axis symmetry, replace x with -x. Makes sense because when you're trying to determine what to do, think of x squared. X squared has y equals x squared is symmetric about the y-axis. +2, -2, +3, -3. So replace x with -x, x with -x. So replace x with -x. And if you get the original, if you get the original equation then it is symmetric about the y-axis. All right, so to determine if a relation has y-axis symmetry, you replace x with negative x, and if you get the original equation, then it is symmetric about the y-axis. All right, so let's look at an example with y-axis symmetry. So for example, let's suppose we had this. So the directions will say this. So example, does this relation, y equal negative x to the fourth plus 6x squared plus 4, does this relation have y-axis symmetry? Okay, so does this relation, remember relation is a set of ordered pairs, so you can represent a relation as an equation because this would be a set of ordered pairs if you use a t-table. But again, does this relation have y-axis symmetry? Well, remember, if you're talking about y-axis symmetry, you have to replace x with negative x. All right, so replace x with negative x. So wherever you see the variable x, you're going to substitute negative x. All right, so here's what you're going to say. You're going to say y equals the opposite, x. Now remember x, right? So if you need to, let me go ahead and use a different color pen. If you need to, you may want to circle the variable x here if you need to, and then just remember negative. So you circle the x, right? So put that in parentheses. You're going to put negative x though, and you're going to raise to the fourth power. Then you can say plus 6 times in parentheses negative x, but that's being squared, and then don't forget plus 4. All right, so that's your first step. So your first step is to replace x with negative x, and then you simplify. Okay, so you got to remember a negative raised to the fourth power, a negative raised to an even power is always positive. So make sure you see that this right here that I boxed off, make sure you understand that negative x times negative x times negative x times negative x is x to the fourth power. So this becomes y equals negative, and this is that I have boxed off is x to the fourth. You do the same thing with this. So you see, if you box things off, it helps you. It helps you to organize your thought processes. So let's think about negative x squared. Remember, negative x squared, I'm going to go ahead and write it here. Negative x squared means negative x times negative x, which is a positive x squared. A negative times a negative is a positive. So this becomes plus 6x squared, and then plus 4. All right, now once you simplify, you compare this with the original. What do you notice about this and the original? Are they the same? Yes, they are. So they're the same. So if what you end up with is the same as the original equation, then you're going to say this. So you're going to say y equals, so you're going to say answer, y equals negative x to the fourth plus 6x squared plus 4 has y-axis symmetry. Okay? All right, so that's a process you're going to go through. Now, this was y-axis symmetry. We're going to come back and do a couple more examples, but this was what you're going to do for y-axis symmetry. So remember, y-axis symmetry, you got to remember, you got to replace x with negative x. And it's easy to remember this. Think of y equals x squared. Y equals x squared is symmetric about the y-axis. So 2, 4, and negative 2 4s on the graph. So 2, negative 2, 3, negative 3. X. So whatever this is, if this is xy right here, this point xy, then the point negative xy is also on the graph. All right, so notice that these distances here, this distance is the same as this distance. That distance is the same as that distance. That distance is the same as that distance. Okay, so if you reflect it, you get that same, the x values are just opposites, the y value stays the same. All right, so that is y-axis symmetry. Okay, now let's talk about x-axis symmetry. So let's look at that one. So x-axis symmetry. Now, let me write this down. X-axis symmetry. Okay, so let's look at this example for x-axis symmetry. So let me get this right here. Okay, so I'm hoping you see this. I'm hoping that you see that this relation is symmetric about the x-axis. I'm hoping you see that. This part here, if you reflect it about the x-axis, here's the x-axis right here. Okay, that's the x-axis. So reflected by the x-axis, you get this part here. Okay, so that right here is x-axis symmetry. And by the way, you don't have to know this, but this is the equation of this relation right here. Now be careful. This is not a function, right? Because it fails the vertical line test. So that's not a function, but it is a relation. And a relation, some relations does have x-axis symmetry. All right, so that's why we're talking about relations here. We're not talking about functions in general. We're talking about relations. All right, so this is relations. And then that, by the way, is the equation of this graph right here. But make sure you understand that this relation right here has x-axis symmetry, meaning this. Hey, I'm going to look at this point right here. See this point right here? That's the point 1, 6. If I take this point right here and reflect it about the x-axis, remember this is the x-axis right here, to reflect about the x-axis, I get this point right here. Okay? And that point right here is the point 1, -6. This distance is the same as that distance. So I want you to notice something this time. So when we talked about y-axis symmetry, the x-coordinates were opposites, right? 2, -2, 3, -3. This time we're talking about reflecting it about the x-axis. This time the x-coordinates are the same, but the y-coordinates are opposites. The y-coordinates are opposites. So this right here has x-axis symmetry. So it's very easy to think about what you need to do. So if you have a point, just think of a point here. You reflected about the y-axis. Notice the x-coordinate is the same, but the y-coordinates are opposites. So for x-axis symmetry, you're going to replace y 6, -6. This point right here is -3, 2 right here, -3, 2. Reflected about the x-axis, I get this point here, which is -3, -2. So notice 2, -2, the y-coordinates are opposites. The x-coordinates are the same, the y-coordinates are opposites. So to determine if the relation has x-axis symmetry, you replace y with -y. To determine if a relation has y-axis symmetry, you replace x with -x. X-axis symmetry, replace y with -y. And if you end up with the original equation, then the relation has x-axis symmetry. Okay, so to determine if a relation has x-axis symmetry, you replace y with -y. And after you simplify and you do all that stuff, if what you end up with looks exactly like the original, then it has x-axis symmetry. So let's look at an example. So let's look at this one. Okay, example. Determine if, and let's do this one, y squared minus 2y to the 4th equals 6x. So y squared minus 2y to the 4th equals 6x has x-axis symmetry. All right, so determine if if the graph of this relation has x-axis symmetry. All right, so on your worksheet and on test 3, you're going to have to do this. Sometimes they have this in the final exam, not always, but sometimes they do. And if you take calculus, you're going to have to know about symmetry. So be aware of that. So if you want to determine if this equation, if this relation has x-axis symmetry in terms of its graph, you replace y with negative y. So wherever we see the variable y, so I'm going to do it just like we did the other. I'm going to circle the y's. Only circle the y's this time because that's what you're going to replace. You're going to replace the y with negative y. Notice I didn't circle the x. It was just like the other one. So in the other one, where we had to replace x with negative x, I circled the x's only. Okay? And then wherever I saw the x, I substitute negative x. So this time, wherever I see the y's, which I have circled, I'm going to replace it with negative y. But just like before, since I have it circled and it's being raised to a power, put that in parentheses. So x-axis symmetry, you're going to replace y with negative y. So this becomes parentheses negative y squared minus 2 times negative y to the fourth equals 6x. So wherever I saw the y, I substitute negative y. Now at this point, you have to simplify this. So you got to remember, negative y squared means negative y times negative y, which is a positive y squared. So this right here is y squared, okay? Minus 2 times, okay, let's talk about this one now. I'm going to circle this, or box this off. So negative y to the fourth means, negative y to the fourth means negative y times negative y times negative y times negative y. A negative times a negative times a negative times a negative is a positive. Y times y times y times y is y to the fourth. So that I have boxed is just y to the fourth equals 6x. Now once you do that, then compare this with the original. Notice that this looks exactly like this. So they're the same. So if they're the same, then the original equation, which is this, then y squared minus 2y to the fourth equals 6x, has x-axis symmetry. Okay? And so that's what you do to determine if the x-axis symmetry. You replace y with negative y, simplify the result, compare to the original. If it's the same, then it has x-axis symmetry. If it's not the same, we're going to do it in a little while. If it's not the same, then you're going to say it does not have x-axis symmetry. So let's look at one like that. So let's do this one. All right, so let's look at this example. So example. All right, so let's see. Let's do, let's try this one. Example. Determine if y squared, which equals 5, I'm sorry, let me redo this. Y squared, which equals x to the fifth minus 7x, determine if the graph of this relation has y-axis symmetry. All right, so determine that has y-axis symmetry. All right, we're talking about y-axis symmetry, so it's important to remember what to do. If you're talking about y-axis symmetry, what I would do, if you can't remember, what I would do is this. I would draw on the side in my mind, I would draw something like this. I would draw a graph that's symmetric about the y-axis. And then I would think about this point. So if that point is xy, then this point here, where reflected about the y-axis, would be negative xy. And right away, I know that the opposites are the x's. So you replace x with negative x. So replace x with negative x. All right, and then at this point, wherever I see the variable x, I'm going to circle it. And then I'm going to remind myself that when I write this next piece right here, this next part, I'm going to put the negative x in parentheses wherever I saw the x. So I'm going to get this now. So I get y squared equals parentheses negative x to the fifth minus 7 times negative x. All right, now, just like we did in the previous problem, this right here that I had boxed off and this right here where we worked it out, you may want to do this. You may want to, in your mind, think of this or write it out on a piece of paper. So let's talk about what this means right here. So I'm going to box this off right here, and then we'll look at this together. Okay, so remember, negative x to the fifth, remember a negative number raised to an odd power. This is odd this time, right? So a negative number raised to an odd power is negative. So a negative x times a negative x times a negative x times a negative x times a negative x. So negative x to the fifth. A negative times a negative is a positive times a negative is a negative times a negative is a positive, and a positive times a negative is a negative. And then x times x times x times x times x is x to the fifth. So this right here, so we get y squared equals, so this right here becomes negative x to the fifth. So negative x in parentheses raised to the fifth is negative x to the fifth without parentheses. And then a negative 7 times a negative x is a positive 7x. Okay, so once you simplify, then you compare this with this. And then you ask yourself, are they the same or are they different? Notice this is not the same as this. The y squareds are the same, right? In order for them to be the same, in order for you to be able to say they're the same, then every term on each side has to look exactly alike. Y squared, negative 2y to the fourth, negative 2y to the fourth, 6x, 6x. Here, though, the y squareds are the same, but this is x to the fifth, and this is negative x to the fifth. And even over here, it's different. Negative 7x, positive 7x, so that's different. So then what you're going to say, based on the directions, remember the direction says determine if the graph of this relation has y-axis symmetry. You're going to say this. You're going to say the answer. You're going to say, you go back to the original, you're going to write the original over. You're going to say y squared, which equals x to the fifth, minus 7x, does not have y-axis symmetry. Okay, so that's how you're going to do these. So it's just a matter of you replacing y with negative y, negative x with negative x, depending on whether you want to determine if you have y-axis symmetry or x-axis symmetry. Now, as you do on the worksheet, it's important you understand what I'm about to say. On the worksheet, when you replace, I need to see this right here, and I need to see the simplified version. And I need you to indicate this arrow and tell me whether it's the same or different, and then you write your answer. All right, so make sure you're looking at this when you do that worksheet. Okay, now remember we can talk about some relations that have symmetry with respect to the x-axis, the y-axis, but also the origin. The origin. So let's look at the origin. Let's look at that one for a moment. All right, so for that one, and let me go ahead and write this right here. Symmetry with respect to the origin. All right, so, oops, I spelled origin wrong, sorry. O-R-I-G-I-N, okay, origin. So let's look at this graph. So I'm letting you know now that this graph has symmetry with respect to the origin. Here's the origin right here, okay? That's the origin. And I want you to notice something. So this right here has origin symmetry. Origin symmetry. And I want you to notice something. You see this point right here? That point here, which is 1, 1? 1, 1. If I reflected about the origin, that's why it's called origin symmetry. You're reflecting about the origin, not the y-axis, not the x-axis, but the origin. Remember, the origin is where the two axes intersect. Okay, that's the origin right here. So you reflect about the origin, you get this point here. I want you to notice something. That point is negative 1, negative 1. If you look at this point here, right here, this is the point 2, 8. and you reflect it about the origin. So you take this, reflect about the origin, you're going to get this point here. So that distance, same as that distance here. So you get this point here. I want you to notice the coordinates though, -2, -8. What do you notice about these coordinates? Both the x coordinates are opposites and the y coordinates are opposites. Both the x coordinates are opposites, 2, -2, and the y coordinates are opposites, 8, -8. So whenever you have origin symmetry, so to determine if you have origin symmetry, replace x with -x and y with -y. So this time you do both of them. 2, -2, 8, -8, 1, -1, 1, -1. Okay? So, and then if you get the original equation, then it has origin symmetry. It has origin symmetry. Okay? So let's look at an example with origin symmetry. Let's look at, let's look at this one. So, example. Determine if this relation, and let's say we have y equals x cubed minus 2x. So y equals x cubed minus 2x. So determine if that relation, if the graph of that relation has origin symmetry. Okay, so to determine if you have origin symmetry, that's where you do both. Okay, you do both. And I want you to understand something, why we do both. Listen carefully about what to say. All right, so you see this point right here? If I take this point right here, reflect it about the y-axis, and I'm going to put that in red just to show you something. If I take this point, reflect it about the y-axis. So if I reflect it about the y-axis, I get 2, 8 becomes -2, 8. Then take that, reflect it about the x-axis, -2, 8 becomes -2, -8. So remember, origin, reflect about the origin, you get that point here. You can also get that point by reflecting about the y-axis and then reflecting about the x-axis. So that's why you see that. Reflect about the y-axis and then reflect about the x-axis. All right, that's why you see both of them, because every point, if you have origin symmetry, this point right here, reflect about the origin, you'll get this point right here, whatever that is. You can also get it by reflecting about the y-axis and then reflecting about the x-axis. So that's why you see both. All right, now let's go back to this problem. So if I want to determine if the graph of this relation has origin symmetry, two things, remember, you got to replace y with -y and x with -x. All right, so I'm circling everything that I see has a y and an x, all this. So y becomes -y. So I get -y equal x becomes -x. -x in parentheses cubed minus 2 times x becomes -x. So y becomes -y, x becomes -x, x becomes -x. So I have to see that. I must always see this. I must always see your substitution. Then you're going to simplify. -y, you can't do anything with. It stays -y. But you all know how to rewrite this. You know that -x to the third power means -x times -x times -x. A negative times a negative times a negative is a negative. X times x times x is x cubed. So -x cubed, that's in parentheses right here can be written as negative x cubed without parentheses. This right here, negative 2 times a negative x, is a positive 2x. All right, now, this is what confuses students. They look at this right here, and they compare it to the original. And they say, well, that's not the same. Well, it actually is. It actually is the same. And so listen there, sometimes you're going to have to do what I'm about to tell you. The previous problems are fairly easy to think about. This one is not. You got to listen to what I'm about to tell you. Remember, one of the properties you've learned is that what you do to one side of an equation, you do to the other side. So you see how I have negative y, this is positive y? I have negative x cubed, this is positive x cubed. I have positive 2x, this is negative x, negative 2x. Those are opposites, right? So if I'm going to go ahead and rewrite this over. So if I were to multiply both sides by -1, which I can do mathematically, that's something I can do. What I do to one side, I do to the other though. So if I multiply both sides by -1, -1 times negative y is a positive y, and then distribute, -1 times a negative x cubed is a positive x cubed, -1 times a positive 2x is a negative 2x, then you notice those are the same. So that's a little, that's one where, and you're going to see this, so that's one where you got to remember, hey, if they're opposites though, then all I can do is multiply both sides by -1 and I'll get the exact same equation. So now since those equations are the same, I can say this. The answer, you're going to say the original equation, which is this, y equals x cubed minus 2x, has origin symmetry. Okay? All right, so far we've learned this. Test for symmetry. So this is going to be test for symmetry. All right, test for symmetry. All right, so to test for y-axis symmetry, let's see if some of you remember what to do. So if you want to test for y-axis symmetry, you're going to replace, and it's easy to kind of remember as well because you do the opposite of what variable you see here. So instead of saying replace y, we're going to do x. So replace x with negative x. And if what you end up with is the same, then it has y-axis symmetry. So if you get the original equation, then it has y-axis symmetry. Okay, now let's talk about x-axis symmetry. So to test for x-axis symmetry, you replace y with negative y. Replace y with negative y. And again, if you get the original equation, then it has x-axis symmetry. And then finally what you learned was origin symmetry. So origin symmetry is where you do both. Because remember when we talked about origin symmetry, keep this in your mind. You take this point, reflect about the y-axis, and then reflect it about the x-axis, you get that other point back. Reflect this about the y-axis, about the x-axis, you get this point here. Reflect this right here, 1, 1, about the y-axis, then reflect about the x-axis, sorry, right here. So reflect about the x-axis, you get that point here. So you do both. So replace x with negative x and y with negative y. And again, this arrow applies. If you get the original equation, then you can say it has origin symmetry. Okay, so let's look at one more problem, and so let's look at this. Let me find where those problems were located. Let's see. All right, let's do this one. So, all right. So directions. All right, directions. So determine if y equals x divided by x squared plus 5 has x-axis symmetry, y-axis symmetry, or origin symmetry. Okay, and it may not have any of them. All right, but the question is, does it have x-axis symmetry? Do the work, yes or no? Does it have y-axis symmetry? Do the work, yes or no? Does it have origin symmetry? Do the work, yes or no? All right, so let's do this one first. All right, so to determine if it has x-axis symmetry, remember x-axis, you replace y with negative y. Okay, so this right here, you're going to replace with negative y. And notice all the others are x's, right? So do you leave those alone? This is the only one you do. So if you want to rewrite, you can rewrite it. Let's do this. Okay, so if we stay consistent, I'm going to circle this. So I'm going to replace this with negative y. So negative y equals x divided by x squared plus 5. All right. Now, notice those two, and there's nothing else going to do with negative y. Those two are not the same. The right-hand sides are the same, right? You can see those are exactly the same, but these are not the same. And you may say, well, can I multiply by negative 1 like we did in that other problem? The only time, let me show you what I'm talking about right here. The only time you want to do that right here is if you notice every term, its opposite is what you see. Y, negative y. X cubed, negative x cubed. Negative 2x, positive 2x. Then if you multiply both sides by negative 1, you get the exact same again. But here, I want you to notice, these are opposites, but these are the same. So those are different. So you're going to say, it does not have x-axis symmetry. Okay, so let's look at this one now. Y-axis symmetry. For y-axis symmetry, you replace x with negative x. Replace x with negative x. So let me go ahead and rewrite this over. So we have y equal x divided by x squared plus 5. And so wherever we see the variable x, I'm going to circle it because now I've got to replace what I've circled. I have to replace what I've circled with negative x. So you're going to write this. You're going to say y equals negative x divided by negative x in parentheses squared. That's important to remember. You got to do this right here. Negative x in parentheses plus 5. Then simplify. Y equals negative x stays negative x, but all of you know that a negative x times itself is a positive x squared. So this right here becomes this. Now let's compare. Is this the same as this? They're not. The left-hand sides are the same, but the right-hand sides are different. In fact, those are opposites. But then that takes us back to this. One side was opposite, the other side was the same. One side is opposite, the other side I'm sorry, one side's the same, the other side are opposites. So they're different. So it does not have Y-axis symmetry. Okay? So let's do the origin. Let's talk about that then. So let's remember for the origin you replace x with negative x and y with negative y. So I'm going to rewrite this over. So we have y equal x divided by x squared plus 5. Okay? And so I'm going to circle all the variables because according to the origin, for origin symmetry, I've got to replace all the variables with the negative component. So this becomes negative y equals negative x divided by negative x squared plus 5. All right, now we're going to simplify. So this stays negative y equal, the numerator stays negative x, the denominator negative x, that's negative x right here, negative x squared means negative x times itself, which is a positive x squared. So I get x squared plus 5. Now, I want you to notice something. This and this. Y, negative y. X, negative x. Those are opposites, right? Just like when we did this. Every term here is the opposite of the original. So that means if I multiply both sides by negative 1, I get the original back. Negative y, positive y. Positive x, negative x. Those are opposites. Those sides are opposites of each other. So which means this. I want you to think about this. We'll go ahead and write this over. Negative y equals negative x divided by x squared plus 5. Meaning this. If I take this side, multiply by negative 1, and take this side, multiply by negative 1, I better get the original. A negative 1 times a negative y is a positive y. A negative x times a negative 1, remember I can write this negative 1 over 1, a negative times a negative is a positive. So a negative x times a negative 1 is a positive x. X squared plus 5 times 1 is x squared plus 5. Now you see those are the same? Those are the same now. So you're going to say answer, the original equation, which is this. So answer, y equal x divided by x squared plus 5 has origin symmetry. All right? And that's what you do. So to test for symmetry with respect to the x-axis, you replace y with negative y. Do all the work and then see if they're the same or different. Y-axis symmetry, replace x with negative x. Do the same thing. Origin, you do both. X with negative x, y with negative x. Do all the work and then compare. And that's all this is. All right, that's all you do for for testing whether a relation has symmetry with respect to the x-axis, the y-axis, or the origin. All right, now I'm going to just tell you there are students that do have difficulty with symmetry with all these substitutions. You've got to do the best you can with mastering this. And the Academic Learning Center has virtual tutors. I'm hoping that you've been using that service, because if you are taking an advanced course in math, going further, knowing this is going to be important. All right, so that's testing for symmetry, and that's all you do. There are students that do have difficulty with this, but for the most part, it's not a total loss. I mean, most students, almost all students, understand some aspects of it, but the more they do, the better they understand. So if all you do is just a couple of problems and then say, I'm done, if you understand, great. If not, you got to do more. Okay? All right. So that is symmetry. All right. So I'm going to turn this video off, and then we're going to look at the next one.